Hello everyone, my name is Adrien de Beaupre and I'm a SANS instructor. I'm the tester of the pens. I also operate a small company here in Ottawa, Ontario, Canada called Intrusion.ca Inc. And I want to talk to you today about a web application issue, a vulnerability that's called Cross Site Request Forgery. But I also want to talk to you about something that we developed as a team when I was working on a large pen test called multi-post cross request forgery. So I'm going to preface that by saying, first I'm going to talk about cross request forgery, then I'm going to talk about multi-post, and then we're going to talk about the specific application that I tested with the team, and then another application I found that's vulnerable to the same thing. So here we go. First we're going to talk about web vulnerabilities in general. We're going to get very specific about cross-site scripting and cross request forgery and how they're related and how they help each other out. I'm going to show you some code and I'm going to run a demo. And the comment I made yesterday or the other day to a friend of mine was, you really have to remember to sacrifice the goat to the demo gods, otherwise your demo doesn't go well. Having said that, I also have to preface that by saying I don't actually sacrifice the goat. You should realize that. It's probably illegal, probably not fun for the goat, and we have a question. Oh, no, this is to comment on the site not working well. So hopefully everyone was able to log in. So I was doing a pen test, and one of the things about the penetration testing is, one, I enjoy doing them, and I tend to giggle and laugh with glee when I find stuff, which is unprofessional, so I try not to do it when my clients are around. But I also like to teach people how to do penetration testing in the way that SANS likes to call doing it correctly. So we try not to do it in the way that some other pen testers, quote unquote, do it, in that they really just run a scanner and regurgitate the results. And as I said to one client last week, in fact, they asked me which tool I used to identify the vulnerability I discovered in their application. And I said, well, I used a web browser and the stuff between my ears, the gray matter. And they really didn't like that answer. They insisted, well, no, you had to run a tool. What tool produced that? And I said, honestly, it actually was a web browser, and I did use an interception proxy, but that was the tool. Well, no, actually the interception proxy just let me see the interaction between the browser and the server. It didn't really identify the issue. Really, I had to look at the code itself and identify the issue in your application. But one of the points I always want to make when I talk about pen testing is, when you run your automated scanner, because let's face it, we all do. I do run automated scanners, of course I do. But one of the things you want to look at is looking at the vulnerabilities in conjunction and in combination with each other. For example, later in a couple minutes, I'm going to show you cross-site scripting and cross request forgery and how they work together as cousins, so to speak, to affect a much larger issue, to really truly demonstrate risk. Because when you look at one vulnerability in an application or a system, it doesn't truly identify the risk or the impact of that actual exploitation unless you can take it in conjunction with other things. So what do I mean by that? So for example, if you have a vulnerability in a web server sitting in a DMZ or a DMZ, as the case may be, that doesn't truly demonstrate the risk to the other systems inside the DMZ. For example, if I can pop the web server, from that web server I can perhaps pivot and pillage other systems inside the DMZ that I could not see from the outside looking inwards. I could only see them from the perspective of the web server inside. So that truly demonstrates risk by pillaging and pivoting, stealing all the things, hacking all the things, of course, within scope and within the rules of engagement. So we were pen testing this one particular application as a group. We were doing it as a team. We'd been doing it for several months, in fact. It was an enormous, truly gargantuan application that was going to be used by multiple enterprises. And the funny thing was, the more we looked, the more vulnerabilities we found. And the list started to get quite long. Now, one of the things I say when I teach pen testing for SANS in particular, I teach both the 560, the network pen testing class, and the 542 and the 642, the web app pen testing courses and advanced web app pen testing courses, is that sometimes it's hard to write a report where you find nothing, right? If you find nothing in the application, then, the client might wonder, or people might wonder, well, what did you do? Did you actually, do any testing? So that's a hard report to write. But the other report that's actually kind of hard to write is when you find so many vulnerabilities that the list of things that it is vulnerable to becomes longer than the list of things it is not vulnerable to. That's really hard to write because you have to basically tell the client, I had to invent new words to describe how bad this thing truly is. That's what actually kind of hard to write as well. So the kind of things this particular application was vulnerable to was A, content could be framed. Now, that doesn't seem important, like so what? So they didn't set the X-frames option, so they didn't have the HTTP header in there. So the content from the real legitimate application could be framed inside other pages. This becomes particularly important when we talk about the attack we're going to look at in a couple minutes because that issue was there, all of the other parts of the exploitation of all of the vulnerabilities together became much, much easier. And I'm going to show you that in a minute. So it was also vulnerable to cross-site scripting. It was vulnerable to persistent and reflected cross-site scripting. Almost most importantly, it was vulnerable to admin persistent cross-site scripting, meaning that if a user could store content on the application server, other users would see that content, it would execute in their browser, and in particularly, the very first person to see that content would be the administrator of the application. Again, we'll get to that in a sec. The method interchange was interesting because the application allowed transactions to be done as post and expected most transactions to be done as a post, where the headers and the content are separate, and most people believe that, for whatever reason, a post is more secure because all of the parameters are passed as payload. But this application would perfectly happily take the same thing, the exact same parameters, as a GET on the URL line. So that method interchange, again, in of itself, not that important. In fact, kind of irrelevant overall. But it made, again, the rest of the attack much more simple and easier to pull off as the attacker. The Cross Site Request Forgery. So the Cross Site Request Forgery allowed an attacker supplied transaction to be pulled off by an authenticated user. Now I'm going to explain much more about cross-site scripting and cross-site request forgery in a second, but essentially these all together allowed an attacker to fully control the application, in effect locking out the administrator such that the administrator of the application was no longer the administrator of the application, the attacker was. Now the last two things were kind of funny. We've discovered that if we went through the password reset function, you say, I forgot my password, and you type in administrator and say, oh, administrator, would you like me to email you your password reset? And if you said yes, well, it would go off to the email of the administrator. But that told you that the administrator account did exist. The other thing that was interesting was that it would tell you that user was not found. If I typed in Adrien as the password reset function, it would say Adrien not found. Interesting. Now the last one was extremely funny. We were able to log into the application, and once we authenticated to the application, we could see the types of functions that the administrators could do. And we could see that the administrator could disable other people's accounts, which is kind of thing you'd expect the administrator to be able to do. But here's the funny thing. If the administrator typed in their own account, they were disabled. Now this is just a short list. There are actually a number of other things that the application was vulnerable to, all of which added together really, really made it interesting. So we sat down once we identified all these issues and said, okay, well, what's the scenario? What kinds of things would we really want to do this application to really show the true risk of A, the attacker being able to pillage by identifying all of these issues, steal information from the application, and then make use of it and truly pivot into the application and become the administrator. Whoopsie, what happened there? Do we have a question? Oops, I have lost the ability to see the questions. Oh, that's not good. So good question, Thomas. So when we logged in as administrator, we basically went to the administrator account and said, we saw that there was a button that said disable. So we clicked it. We logged out. We would try and log back in, and we could not log back in as administrator. So we thought that was kind of funny. It was a feature where they'd allowed all of the accounts to be disabled, which is interesting because they didn't think of, well, should administrators be able to disable themselves? And they left it there. I guess they either didn't think of it, or they did think of it and they thought it would be a good idea if one administrator could disable another administrator account. So I don't know if they thought of it as a flaw, but it really made exploitation of this particular application much more interesting, and you'll see why in a sec. Does that answer your question? Awesome, thank you. So cross-site scripting. You may have heard of this flaw before. It's possibly one of my top most favorite exploitation techniques. Not in of itself. Essentially, cross-site scripting gives the attacker the ability to inject a script. And where the script runs is in another user's browser. So I don't consider this really an attack against the application. What I consider cross-site scripting is an attack from one user against other users. So the coolest part of this application was it had a help desk function. Any user could create a trouble ticket. Inside the trouble ticket, they could put their script in. Now the other interesting thing was the very first person to see every ticket was the administrator of the application. The administrator would then take the ticket, do some sort of prioritization, some sort of triage, and then assign it to a help desk agent. But that first capability, the fact that the administrator had to see every ticket, was, in our view, the ticket to the kingdom. So what would we want to inject in there? Well, we'd want to inject a script that would do interesting things. In fact, the interesting thing we'd want to pull off was we would take advantage of the other flaws I'm going to mention in a sec, the cross request forgery. All of the cross request forgery attacks that were most interesting could be performed by the administrator. So if you think about it, the administrator gets the cross-site scripting attack first. The attack in the cross-site scripting, the script runs the cross-request forgery. The cross-request forgery attack running in the browser does all the things that the administrator can do. Well, what can the administrator do? You'll see in a sec. So, cross-request forgery. This is where it gets interesting. So the user is logged in, the victim. The victim clicks on a link or the cross-site scripting attack runs. Whatever the script runs in their browser to the application appears to come from that user. And that's the neat thing, is that it appears to be a valid and authenticated application transaction. So what would the attacker want to do? Well, it depends on the application. Imagine a banking transaction. Would you want all your money transferred to the Cayman Islands? No. Probably not. But to the attacker, that would be an attractive transaction. They would want to transfer your money somewhere else. So if they could do a cross-request forgery attack, imagine you're sitting in your browser, you see an email. In the email, you see a link. The link points to your bank, in fact, and says, hey, click on this. You click on it while you're logged into your bank, and boom, all your money's gone. Now that's kind of nasty and not that easily done, because you know what? Most banks should hopefully have already heard of this cross-request forgery thing, and they should have made their application less vulnerable or mitigated the vulnerability within their application. But what we find is, yes, in high visibility applications, in applications that people use all the time, most of them, they have mitigated cross-request forgery. What we find is a lot of the other applications, especially internal applications, are still ripe for the picking for the attackers. So imagine, for example, an internal HR application where one user can see or change the salary of all the other people inside the organization. That's where we're finding cross-request forgery a lot of times these days. So I consider cross-site scripting and cross-request forgery are kind of like cousins. They really, really help each other out. So they're kind of sneaky, nasty, mischievous cousins. Not the kind of cousins that you want to have, but they like each other a lot. They help each other a lot. So the persistent cross-site scripting that the administrator had to run will run the cross-request forgery. Now, here's where it gets interesting. We were faced with this in our true pen test where we wanted to pull off more than one transaction. And we thought to ourselves, well, can we get the administrator to click more than once? And if we can't get the administrator to click more than once, how are we going to do more than one transaction? So literally, we were sitting there and we started Googling. How do we do more than one post in one form? Or more than one form with more than one post in one page? And believe it or not, our Google foo was with us that day. We actually found a post by a gentleman by the name of Tim Tomes, and he described the technique. So we took his technique and wrote our own code that worked within this particular application to pull off more than one transaction, and we called it multi-post cross-request forgery. So the requirements for cross-request forgery are pretty simple. The user has to be either currently logged in, or they do have a cookie in their browser that is still valid, or single sign-on. Single sign-on makes cross-request forgery brilliant because if the user clicks on a link with single sign-on, whatever they're signed into or want to be signed into, they are signed into automatically in the background. So on public visible applications, we're seeing this less and less. But as I mentioned previously, on internal applications, especially where single sign-on exists, this is rampant. We're seeing it everywhere. We're seeing cross-request forgery in all kinds of interesting applications that we shouldn't, and we're finding interesting ways to exploit them. So the next thing about cross-request forgery is it has to have predictable parameters. Every parameter inside the application for that transaction, the attacker has to know what they are and has to be able to predict values that make sense inside the transaction. Then, if those two are true, the user has a session or can get one, and the transaction is predictable, the victim has to click on a link or gets to cross a scripting attack. The last thing, of course, is the transaction has to be attractive. Now, when I'm going to talk about the cross-request forgery attack inside the application, one of the things it was vulnerable to was the logout button. You're thinking, well, again, so what? The logout button, you could force other users to log out. It becomes interesting if we first disable the administrator account and then log them out. They can't log back in. Now, we've seen cases where either the attacker has knowledge of the above, meaning they have knowledge of the application. They can either download the source code, or they are a user, or they are authorized. This is beautiful from a nasty sense from the insider attacker point of view. Or they just happen to be very, very lucky, perhaps less often than not. So here are the functions inside the application that were interesting to cross-request forgery. All of them had to be performed as administrator. First of all, the administrator could add a user. Okay. The administrator could change or set the user's password. The administrator could put that user into a group. In particular, any administrator could put any other user into the administrator's group. The administrator can disable any user, including themselves, and the administrator could log out. And all of these were cross-request forgery functions, meaning every parameter was predictable and could be attacker supplied if the attacker could get the administrator to click on a link, or going back to my earlier point, if we have persistent administrator cross-site scripting, all the attacker has to do is insert the trouble ticket with the cross-site scripting attack, launching the cross-request forgery, pulling off all these things, and boom, we're done. So here's the function and the problem we're facing. How do you do them all at once? So we wanted a demo that we could show people how to pull off the entire scenario. We didn't want one vulnerability at a time, no. We wanted all the vulnerabilities put together such that they would truly understand why they had to fix not one of them, not two of them, why truly all of the functions within the application had to be fixed. Now, one of the developers and one of the project managers came back to me and said, Adrien, that's going to take 6 months. And I smiled. Actually, I tried not to smile. I said, you know what? You're probably right. And I was. So we wanted to add a new user. Let's call him Evil Hackswar. Put Evil Hackswar in the administrator group. We want to lock out the administrator account. We want to log out the administrator account. We want to do every function in the right order. And here's the important part. We had to wait for the previous function, meaning we wanted to make sure we added the user first before we locked out the administrator account. We wanted to make sure we locked out the administrator account before we logged them out. So we had to wait for them to all happen. We wanted to put it all in one magic HTML page that we could launch with cross-site scripting. And then, of course, we would rickroll the administrator, right? You know, of course, if you're pulling off this kind of attack, you want to do something really mean, really nasty. You rickroll them. You force them to watch a certain Rick Astley video. I posted this particular attack scenario to the SANS Internet Storm Center site, the isc.sans.edu, and I mentioned the rickroll, and I put in the link, and someone actually clicked on it and commented on the page that they just had to click, right? They had to see what I was talking about. Don't do it. You do not want to see this face. You do not want to hear that song. You know, it's just it's one of those internet memes that, of course, you wish would go away. It doesn't. People still click on the link. They still see Rick Astley. It's just mean. So here's the code. So basically, we wanted to create one HTML page. The one HTML page which would be injected by cross-site scripting. We would have one form per transaction. So for example, add the user would be 1, lock out the administrator would be 2, log out administrator would be 3. We would create 3 different forms, put each form in an iframe. Then we'd have some JavaScript that would launch iframe number 1, wait for it to finish and load, then launch number 2, wait for it to finish and load, then number 3, and do them all in the right order. That's it. That's the simplicity of this attack, in that it takes advantage of all the vulnerabilities I've discussed, all in one shot. It uses the fact that we can frame the code, and we can frame the application. It takes advantage of the fact that we know the administrator exists. It takes advantage of the fact that we know some of the administrator functions are cross-request forgeable. It takes advantage of the fact that we know there's cross-site scripting that's persistent and init bin functions. So all in one. So how do we get the attacker to pull this off? Well, this is the code. Now I'm going to show you the code much better. I just took a snapshot to be funny, to show, you know, welcome to pwnage by CSRF, cross-request forgery. But we're going to look at the actual code. Of course, we're going to run a demo. Now, the problem was, after the fact, I wanted to talk about this stuff in public. You know, it's like, wow, this stuff is pretty cool, this cross-request forgery, this multi-post stuff. And I'm looking at the code that I wrote for the particular exploit that we did, and I realized I couldn't use it. So I had to find an application that was vulnerable to cross-request forgery in the administrator functions. So I found Amica. Amica is a free open source content management application. It's a CRM or whatever, or a CMS. And it's easy to install and easy to exploit. So this is actually not a 0-day. I found this code well over a year ago, and I've been talking about it for a few times since. And they fixed it in the more recent version of Amica. They supposedly have fixed all the problems in Amica. Good for them. So I have the old version, and I'm going to demo my attack in the old version of Amica. So here's Amica. You log in. It, you know, allows you to manage your content, whatever that means. Straightforward, fair enough. But when you added users, you saw, for example, there's a username field, there's a name field, there's an email field, there's a role. For example, super means administrator, and you click on add user. That's what the form looks like to the administrator when they add a user. Here's where it gets interesting. If you look at the function's parameters, there's username equals, name equals, email equals, role equals. They had preset active to 0. If you changed and active equals 1, meaning the account was enabled, and submit equals save changes. So I was looking at this in the interception proxy going, well, I don't see anything in here that's not predictable. Username, name, email, role, active, submit. And as the attacker, if I can see all of them and predict all of them and inject values into all of them, that is cross-request forgery by its very nature. So there's nothing in here. There's no CSRF token. There's no randomness. There's no nonce. There's nothing that's not predictable by the attacker because everything is the same every time. That's the danger of this thing. So I guess the developers didn't consider the fact that cross-request forgery was possible or hadn't heard of it. And I saw this in the browser. I saw this in the interception proxy, and away we went. Now, it wasn't just that. It wasn't just adding users. There's the change password function. Now, can anyone tell me what's missing from this form? New password? new password, save password. So I have 1, 2, 3 parameters. Now, what's the parameter that normally you have in there? So I just noticed there's questions. For someone using Google Apps, would CSRF results be different if the user is logged in Chrome both as administrator? Yes, Gabriel. So it very much depends on the context of which user you are logged in as to the application, because it's to the application that matters. So if you're logged in, for example, as an enterprise admin, and all of your applications use that enterprise admin Windows token to authenticate you, that's the context that Cross Site Request Forgery would run as inside the application. To answer your other question, Thomas, no, logout's not a risky one. Logout's not a big deal if that's the only one, right? So if CSRF is only vulnerable in the logout function, I would say no big deal, move on, who cares? So yes, this is actually an old flaw, it's not a brand new one, but looking at the change password function, I see new password, and I see submit. Can anyone tell me what's missing here? What do you normally see on your change your password? Yeah, where's your old password? Exactly. They didn't think of that. They didn't put it in there. Nowhere does it ask you for your old password, and that's pretty neat. So in the original application we tested, there actually was a disable user button. So in order to pull this off in Omeka, you know what we did? We went to the administrator page and we changed their password to something they didn't know. We just changed their password. That's how we disabled them in Omeka. Because we don't have to know what the old password is to change it to something new. So here it is, new password equals, submit. 3 parameters. They're all obviously known to the attacker. In this case, I'm the attacker, right? We're attacking this application. And I guess this developer just had never heard of that. So once the user clicks on the CSRF load attack, you'll see that there's 1 frame, 2 frames, 3 frames. Of course, we have to pay, we can't pass up an opportunity to say all your base belong to us, because that's just fun. Now, you may wonder, why did we make the frames visible, and why do we say all your base belong to us? Well, there's this old game, this old video, that all your base belong to us. It was written, I believe, in Japanese. It was translated to English. It didn't translate very well. It's basically, we win, right? All your base belong to us. We're the winners, you're not. So we showed the attack in visible iframes. We didn't have to. We could have made them invisible. We could have made them 0 by 0, and we could have had them happily watching a Rick Astley video, the Rick roll. But in this particular case, when I did the original presentation to the C-level execs at that application enterprise, we didn't Rickroll them because it's unprofessional. And you notice that I did not Rickroll you guys because, well, that would just be mean, right? So OWASP Zap is the application I use to identify it. It's an interception proxy. It sits between the browser of the attacker and the application. It allows them to see those snapshots I showed you of the parameters, and it also has the ability to create Cross Site Request Forgery proof of concept code. What I did is I took the proof of concept code from Zap. Beaupre has the same ability, and I then took those 3 different examples of proof of concept code, merged them into one, and pulled off the single attack, as I want to show you in the demo. Now here's the demo. The original write-up on the slide there at isc.sans.edu is the one I wrote to demonstrate this code, and I've been talking about it ever since. Hopefully you are now beginning to understand the incredibly interesting capabilities behind Cross Site Request Forgery. So I'm going to cross my fingers, if you don't mind crossing as well. Please note, no goats were actually harmed. I do make the joke every time I do a demo that I should sacrifice to the demo gods. I don't actually do it. Here's my contact information. I'm going to leave that slide up afterwards as well in case you want to get a hold of me. And I'm going to flip to a VM running. Here is Firefox. It is set to have a local host proxy on 8080. So here's Firefox. What's listening on 8080 is this guy, Z attack proxy. So it goes from the Firefox browser goes through this proxy so we can see it, and then hits the backend web server. But I'm going to break off for a second and show you the code. So here's the initial code, just some comments pointing to the diary entry. Tim Tolmes, Landmaster 53, is the guy's research that I used to develop this code. So basically, on load, run me. Let's skip down to run me. What does run me do? Run me submits CSRF 0 and then waits. What does it wait for? On load. On load of the first one, 0. When the first one 0 loads, then load the second one, number 1. Then number 1 will wait until number 1 finishes loading, and then run CSRF 2, the third one. Once CSRF 3 is submitted, we then do the alert, all your base are belong to us. So basically we run this one, 0, then 1, then 2. That's it. What's in these 3 guys? Well, there's frame 0, frame 1, frame 2. Inside each frame we have a form. So form, its name is CSRF 0. What does it do? It does this function. It does a post to the user's add function. Username, hacker, name, evil, email, hacker@evil. Role is super, active is 1. So we add the user, put the administrators group, and create them as active all in one post. So that's the totality of that form. Then we have form 1, the second one. What does it do? It changes the password of user 1. With this application, user 1 is always the administrator. We changed our password to password with a P in caps and the O as 0. So the last thing I mentioned about Omeka, of course, it allows you to create incredibly stupid passwords, right? Too short, not complex, no real complexity requirements, no real length requirements. And here's the last one. Go to logout. That's it. 3 things, 3 forms in 3 frames, 1 page, submits each one of them, waits until the previous one completes, and then submits the next one. That's the simple beauty of this attack. I should go back and see if there are any questions. Not as of yet. Okay. So let's look at our application. So here, we log in as administrator. And log in. We see, oh, there's administrator, there's foo. Oh, that hacker is back again. Oh, I'm going to delete him. I delete the hacker. So I'm the administrator. In this case, I'm the victim. I'm looking at my application. All is good. I deleted that evil hacker that came back again. How does that hacker keep getting in there? Oh, wait. There's a trouble ticket. I'm going to click on that link. Form 1, Form 2, Form 3. All your base belong to us. The attacker hits OK, or sorry, the victim hits OK, and goes back and, wait, I'm logged out. Now, because I always forget my password for this particular application, for this particular demo, I have to go back here and see that my password is password, PASSW0RD, right? So if the real victim knew, they could log in. And notice that our evil hacker dude is back in the application. They are the super user, and they are active. And that's the simplicity. That's the beauty of this attack. I'm going to show you how this looks from the interception proxy point of view. So here, for this particular post, username administrator, password, remember, submit, login, right? That's for the login. But for the change password, new password, new password. That's it. It's as simple as that. If I wanted to, as the attacker, delete users. See, actually what's interesting is the delete users is hard to pull off because of this hash. I'd have to go back and reverse engineer the code or actually read the code to figure out where that hash came from. It's actually pretty interesting that this would be hard to figure out, unless, of course, I had the code. This is open source code, so I can actually do that. And there's the logout. Logout equals yes. So just looking at this thing from an administrator point of view, from the interception proxy, you can see how individually these vulnerabilities don't seem like such a big deal, but when you put them together, they become, interesting, really much more interesting in that the individual vulnerabilities by themselves don't seem that exciting. They don't seem that traumatic. They don't seem that exciting as far as an impact is concerned. When you put them together, when you combine the vulnerabilities, when you start looking at them from the evil hacker scenario point of view, that's when it gets really interesting. Oh, of course, Thomas, the code is actually on the site I put up. Let's see. Can you see that? Right here, isc.sans.edu/forums/diary/18507. It's way down at the bottom of the page. Omeka is still around. Now, Omeka has been updated to version 2.3. The version that I actually ran this code against was a different, older version. So if you look in here, as the super user, you can see that I'm running a truly old version of Omeka, and it's now up to version 2.3.1. Old versions of Omeka are still around and can still be downloaded, and I have this version, so I have version 2.2 installed here, which is the vulnerable version. As I mentioned, I haven't actually checked, but I believe they were advised by the original person who found this exploit that they had a problem, and they said they fixed it. I didn't actually go back and check, but one of these days I probably will when I have lots of time. So yes, sorry, quick question. Can you have the code? Absolutely. It is right here. isc.sans.edu, forums, diary 18507, or Google my name and XSRF, and you will find it. Wow, good questions, you guys. So the clear thing is, what you want to test is you want to find and prioritize which transactions inside the application are interesting. Once you find an interesting transaction, then you look at all the parameters in that transaction and try to determine if they are vulnerable and if they are predictable. Now, as I mentioned, the one thing that's important here is if one of the parts of the parameters is not predictable by the attacker, the administrator wins, right? So what you do is you add a nonce or a non-predictable token to each and every page, such that every time the page is downloaded, every user gets a different code. And if they download the page a different time, they get a different code. And then the job of the application at that point is to double check. When I gave that user that page, I put in this code. If I get that code back in a parameter, that means it was a legitimate one. If I find a transaction coming back without that code, we reject it. Now, unfortunately, what that does add inside the application is more logic and more tracking of, usually often in a database, of these tokens, the Cross Site Request Forgery nonces, and it also adds a performance hit. So you don't have to test every parameter in every page. What we have to look at is every transaction that's interesting, find parameters that are predictable, and attack them. Alrighty. So Thomas, does that answer that question? Oh, time constraint is always an issue. Every pen test, we always have limited time. you know, every engagement I've ever been on in my entire career, I've been doing pen testing almost exclusively for the past 15 years. I'm never told I have unlimited time. I am never told I have an unlimited budget. I'm always told I have 10 days and, you know, I had to spend 3 of them on reporting and analysis. So you're right, of course. Time constraint is always an issue. There's the 3 major constraints, right? There's scoping, rules of engagement, and overall budget. And they're layer 8 issues that cannot be modified by the pen tester. They're determined by the owner of the application. You know, I've been on engagements where I've been basically been given 20 minutes. You know, let's see how far Adrien can get in 20 minutes, which I consider a little bit unfair, but an interesting challenge. Which tools? I actually wrote an article on the same site, isc.sans.edu, on which tools. So it depends. For web apps, I generally use W3AF, a tool called Acunetics, which is a commercial tool, Burp Suite Pro, which is a commercial tool, and Zap. Those are what I use for web apps, almost exclusively. I might run Nikto and some other stuff, but W3AF and Acunetics are my 2 major scanners. And yes, Jason, of course I'm teaching at Hackfest. So I teach for SANS on a regular basis, usually around once a month. The next time up, I'm teaching 542 in Dubai. Now I understand most of you probably won't be coming to Dubai, but I will be teaching the 642, the advanced web app pen testing class in DC or near DC in Alexandria at the Hackfest Pen Test. You know, Thomas, that's an interesting one. I find that I will often do pen testing in prod because that is the only environment that they have. You know, often there's not a test environment, or the test environment is either incomplete, inadequate, or is actually several revisions ahead of prod. So is it safe to run these tools in production? The answer is no. There's always collateral damage. There's always impact. If there's no impact of a pen test, it's not a pen test. So what we have to do is make the administrators aware of the fact that during the pen test, bad things will happen to the application. Bad things will happen to the environment. You know, Omeka, for example, is fixable. Supposedly they fixed a lot of the issues. In one of these days I should stop saying that and actually go check, but you know, it's not an application that I run. So if you want to run this type of application in production, what you have to do is test it prior to production. And that would be your best case scenario. In your development lifecycle, you add in penetration testing prior to. Now the problem is 9 times out of 10, we're not testing prior to production. We are testing in production. Over 90% of the time, the code that I test only exists in production. There is no test environment, and it was not tested prior to production. So how do I mitigate that, and what other mitigation techniques can I do? Well, honestly, that's negotiation with the client, with the owner of the application. There will be impact, and there is risk in running this test. But my argument is there's more risk in not running this kind of test. So I guess, Gabriel, your other question is, how would you run an unfixable application in production? There's the Band-Aid approach. You install a WAF in front, a web app firewall, and try and determine what logic you want to protect inside the application with the reverse proxy or WAF. But you always have to be aware of the fact that inside the application, you are still vulnerable. So the other thing to do is not just necessarily corrective controls. You can't fix the code in some cases. We have to put in is detective controls. You have to be able to detect when these functions are being abused. And it goes back to something I mentioned earlier, that you have to prioritize and make sure you know which transactions are interesting to the attacker. Doing things like threat modeling and self-targeting. Yes, the recording and the links to all the slides will be posted on the SANS website. I understand there's an issue with the link to getting into the webcast earlier. Hopefully it should be fixed. If not, my contact information is here. And hopefully you can see that. If you can't find it on the SANS website, it should be there. Also, I mentioned that all this code has been posted to the isc.sans.edu site. So if you can't get it from the SANS site, the recording should be there, but I always have the slides. So if you just email me, I'll send you the slides, but they should all be on the SANS website. Oh, thank you. The first time you understood Cross Site Request Forgery. You know, it's an interesting one in that I think it's often misunderstood, but even people who understand it, I think they often misstate or understate the true risk and the real problems with it, which is why I like doing this talk. So this is the kind of stuff that we talk about in SANS courses, and I try and explain it in ways that people understand. Hey, excellent question, Jason. So I actually run a conference in Ottawa called B-Sides Ottawa. There's my hashtag. We actually ran it last weekend. And, I think the best way to get involved in the community is either learn or teach. And teaching teaches you, or you learn a lot more when you teach. So getting out, doing talks like this, going to B-Sides, getting involved in organizing B-Sides. In the States, you have InfraGard. In some areas, I've heard the InfraGard is much more useful than in others, but depending on your community. And just having meetings. We get together here in Ottawa on a monthly basis and run things like B-Sides here. Oh, there we go. Telling me it wants to scan me. Go away. Oh, I just hit scan now, didn't I? That was dumb. Yeah, go away. So actually, no, transaction injection is the name I call CSRF. I never, the words cross request forgery, to me, don't really state what this thing means. What it means is transaction injection, just like cross-site scripting is script injection, really? Because then what does cross-site mean anyway? Nothing against Jeremiah Grossman when he came up with these terms, but I don't like them. I prefer the term script injection for cross-site scripting, and I prefer the term transaction injection for cross-site request forgery. I am probably the only person on the face of the earth who calls them that way. So they're not generic terms. Yes, I made them up. But it's just like the first person who invented the word cloud when they pointed to the Visio diagram and said, hey, that's the internet, let's call it cloud. If you're that first person to create the meme, you win, right? So I'm going to point at databases from now on and call them the cylinder, because that's, the Visio diagram icon is the cylinder for databases. So I'm going to call all databases the cylinder. Alrighty. No, thank you, Thomas. You guys had really, really good questions. You can follow me on Twitter if you want. Thanks for that, Gabriel. It is Canadian Thanksgiving on Monday, so I will be passed out after eating turkey all day Monday. Have a good day, everyone. Thanks for coming to my session, and thanks for helping me just understand cross request forgery and explain it to you. Hopefully you had a good time and found it informative, and I will see you around sometime. Thank you very much.